If you've ever made one of those papier-mâché volcanoes, you know that household acids like vinegar and bases like baking soda react to produce gases, that bubbly lava. But did you know that a similar chemical reaction is what makes cakes and biscuits fluffy? If you see a recipe call for baking soda or baking powder, that's what's helping your tasty baked goods rise. Baking soda and baking powder are just made up of slightly different compounds, which can affect the chemistry of your cooking. Back before grocery stores and fancy cake recipes, if you wanted to make your bread rise, you needed leavening agents from natural sources. And by that, I mean bakers would leave their dough sitting out so that wild yeast from the air could move in. The yeasts digest sugars in the flour and make chemicals like carbon dioxide through a process called fermentation. All that carbon dioxide gas makes the dough slowly rise and create fluffy loaves of bread. Eventually, people started learning to save some of their raw dough or just some of the flour water microbe goop to kickstart the process the next time. We still use this method to make sourdough bread today. And without yeast, bread just doesn't have the texture and flavor we're used to. But around the 1830s, bakers started figuring out that they could create a quick chemical reaction themselves so they didn't have to wait for the yeast to do its thing. That way, other baked goods like cakes and biscuits could be lighter and fluffier. So bakers started using chemical leavening agents like baking soda, which if we were to use the actual chemical name, we would just call it sodium bicarbonate. It's made from soda ash, which at the time came from the ashes of sodium-rich marine plants like seaweeds, or it was made synthetically by reacting table salt, also known as sodium chloride, with other chemicals and minerals. Today, the chemicals needed to produce soda ash and baking soda also come from mines. But the baking soda you find on the supermarket shelves is the same compound that we've been using for almost 2 centuries. Usually, bakers would mix sodium bicarbonate and sour milk, which is full of lactic acid, and the reaction would produce bubbles of carbon dioxide, like the eruption in a science fair volcano. Those gas bubbles can puff up bread dough or cake batter, but the acidity of the sour milk isn't all that consistent, so neither were these reactions or their final baked goods. So the next leap forward in baking technology was in the 1840s with cream of tartar, also known as potassium hydrogen tartrate or potassium bitartrate. It's an acidic byproduct of wine fermentation, and when you mix it with sodium bicarbonate and some water, you get carbon dioxide bubbles. Cream of tartar helped make the chemical reactions in baking more consistent, but there was one big downside. The availability and price varied depending on the grape harvest in a given year. For a while, sodium bicarbonate and cream of tartar were sold in twin packets, which you added to the wet ingredients when you were ready to set off the reaction and stick your batter in the oven. This worked fine for bakers, but the supply of cream of tartar still wasn't consistent. Enter the chemist Ibn Horsford, who figured out how to make an acid called monocalcium phosphate from beef bones in 1856. Like the cream of tartar reaction, when you mix monocalcium phosphate, baking soda, and water, you get carbon dioxide bubbles. So Horsford mixed monocalcium phosphate and sodium bicarbonate together and then added some cornstarch to help keep everything dry and prevent early reactions. He marketed this concoction as Horsford's bread preparation, and voila, baking powder was born. During the 1880s, people realized they could extract monocalcium phosphate from mines instead, no beef bones required. And nowadays, most of the baking powder you'll find at the grocery store is labeled double-acting. Like the name suggests, the sodium bicarbonate in double-acting baking powder reacts twice. Once with an acid when the wet ingredients are added, and then with a second acid because of the heat of the oven. That way, your dough keeps rising while it's baking, and you get a fluffier product. However, some of these heat-activated acids can contain aluminum. Some people avoid double-acting baking powder because they're worried about the health effects of aluminum, although the CDC says the amount people consume in foods isn't enough to be dangerous. Either way, other double-acting baking powders are aluminum-free and use compounds like sodium acid pyrophosphate instead. So there you have it. Baking soda is just another name for sodium bicarbonate, while baking powder is sodium bicarbonate plus an acid or two and some cornstarch. An all-in-one chemical concoction just waiting for moisture and heat to get the reactions going. You can't substitute baking soda for baking powder unless your recipe also includes an acid, something like buttermilk, vinegar, or cream of tartar. So next time you bake a batch of chocolate chip cookies, remember to thank chemistry for that fluffy, chewy goodness. Thanks for watching this episode of SciShow, brought to you by SciShow aprons. I'm not even kidding. It's a thing that we have at dftba.com/scishow, along with a number of other products that you can purchase and display to show your love and appreciation for SciShow. Thanks for representing if you want to. And if you're doing any baking this Thanksgiving season, tweet out your baked goods to us. Hopefully you used the right kind of baking products and things did not go poorly. In honor of Pie Day, we thought that we would talk today about pie. No, not pie. Pie. Tender crust with fruit inside. The filled dessert that is superior to the other.